Okay. So whenever, like I said, we know that there's different ways to calculate the center. And the mean is the one we're interested in here. When you use the mean as the measure of the center, then you use standard deviation as the measure of the spread. If you use the median as the measure of the center, there's another statistic that's called interquartile range, which is the measure of the spread. You don't mix those up. They always go together. Right? The formula for the standard deviation is this, right? Which is, and notice that again, here we get into a little notation mix-up, because here they're saying that sigma, it's a Greek lowercase letter, Greek letter sigma, is what represents standard deviation, right there. Again, they got it wrong when they started saying that mu is the average for the set of data, and it's wrong in the same way to say that sigma is how you say standard deviation for a set of data. It's really X, but that's okay. Notice this notation though. Okay, so we're going to use sigma. That's what's on your sheet. But when you do it in the calculator, what you're going to be looking for is sigma X. Sigma X is how they call standard deviation. Okay. And the formula is this, right? It's the square root of the sum, I equals 1 to n. So we've got the summation notation, the capital Greek letter sigma, of xi minus mu squared divided by n. Okay, xi means each of the data points. So when I substitute I equals 1, x1 would have been my first data value. x2 would have been my second data value. x3, my third data value. So what you do is you subtract the data value minus the mean, which, if the data value is more than the mean, is a positive number. And right? If the data value is less than the mean, it's a negative number. Right? If I tried to just average those, they would cancel each other out every time. That's why you square it, so that all of these differences are positive. So you subtract the data minus the mean and you square it. You add up all those differences and then you divide by how many data do you have. Okay. We don't have to calculate this. We're going to do this with the calculator. In fact, you already calculated it. Okay. You did it by stat calc 1. It was in the list. Right? You saw the X bar and the median, but you actually had the sigma X in there too. Let me show how, with the data values, those 3 lists of 5 numbers, what their standard deviations are. Okay, so let's go back to this. Okay, I'm going to find the mean and the standard deviation for my first data set, what I have in L1, 1, 2, 3, 4, 5. So stat, calc, 1, and if you don't put something after that, it's going to assume you mean L1, right? If you wanted to take from a different list, you got to put in that list. I'm going to put in the L1 just to be clear. L1. And when I hit enter, the mean is 3, which we thought. The standard deviation is here, sigma X, 1.4. Okay. Now let's do the same thing for the second set of values. That'll go stat, calc, 1. This time I'm going to put L2, right? What do you think the standard deviation will be for the list of 5 numbers that were all 3? It's got to be 0, right? It has to be 0 because there's no difference between all the values and the mean. So I hit enter, and notice my sigma X is 0. Right? That's a measure of how much it's spread out, and it's not spread out at all. Right? The last one would be stat, calc, 1, and this time I'll do my L3, and 1.7. So it's more spread out than the first one was. That was about 1.4. That's standard deviation, mean and standard deviation.